So if we move quickly on then to the next slide, here we get a rather prodigious mismatch again between CO2 concentration, which is the black line, and temperature concentration, which is the blue line, going right back to almost 600,000 years into the past. And here we had almost 7,000 parts per million of CO2, compared with 385 or thereby today. 7,000 then. Temperature managed to get up to about 22 Celsius and has never really gone much higher than that at any time over the past half billion years. As best it can be reconstructed. There are, of course, again, difficulties going that far and getting accurate results, but the IPCC itself says that in the Cambrian, carbon dioxide certainly went up, in its opinion, to around 6,000 parts per million, so this is not a controversial graph. What it is controversial is that, again, it doesn't show a terribly good link between the two. And look at how little correlation there is in that graph between temperature in blue there and CO2 concentration in black. Plainly, CO2 is only a bit part player in all this.
What I love about Christopher Monckton is that he doesn't give us fuzzy conclusions based on ambiguities, as do Tim Ball and other critics of climate science. He's like a school student who not only shows his math teacher the answer, but also his workings out to show how he got there. So it's very easy to see exactly where he went wrong. Just check his sums and check his sources. Monckton's sources for no correlation between CO2 and temperature are shown right here. Two researchers, Berner, who compiled a graph showing CO2 levels, and Scotties, who compiled a graph showing temperatures. Put the two together, and you get the graph Monckton used. Scotties hasn't done any analysis of correlation, but Berner has. So let's look at the paper where the data Monckton used was published, which obviously Monckton should have read if he's citing this as his source. We'll read Berner's conclusion together. This means that over the long term there is indeed a correlation between CO2 and paleotemperature as manifested by the atmospheric greenhouse effect. Did Monckton somehow miss this? Dana Royer, who also reviewed all the data on past temperatures and CO2 levels in a landmark paper, also concluded that there's a clear correlation throughout the Phanerozoic. You may find this a bit odd because the graph Monckton showed his audiences obviously shows no correlation at all. So either geologists are in on this global conspiracy with climatologists and are lying through their teeth in order to set up a world Marxist government, or there's something they know that's missing from Monckton's graph. For those who share Monckton's confusion, let me again use the analogy of a heater in a mountain cabin and see if you can work out what that missing something might be. Remember, the warming effect of CO2 is the output of our heater, and the cabin is the Earth. If there's a correlation, then whenever we turn up the heater, the cabin should warm up. When we turn the heater down, the cabin will cool down. So let's see how they correlate over a 6-month period. If we start our graph on January 1st, the heat is way up high, and the temperature of the cabin is toasty and warm. During a cold snap, I turn the heater up a bit, but I still freeze my nuts off. In the spring, I begin to turn the heater down, and so it goes on with the cabin temperature remaining reasonably equitable until we reach today, July 1st. This is a fairly typical output from most home heating systems between January and July. Over time, we can plot the output of the heater and the corresponding temperature, and we can see there's no bloody correlation at all. But how come? The only possible conclusion is that the heater does not affect the temperature of the cabin. When you think about it, it's obvious, because here the heater was turned up much higher than today, and yet the cabin was much cooler. But before you believe someone who tells you this means you can turn up the heater in the middle of summer and it won't make life in the cabin unbearably hot, you might want to find out why the experts disagree. Actually, I hope everyone is smart enough to have figured out why there's no correlation. When I began heating the cabin on January 1st, it was midwinter and solar irradiation was very low. When I finished plotting the graph on July 1st, it was midsummer. What's missing from our graph is the most important heat source of all, the sun. But surely the analogy isn't the same as the Earth, because the sun obviously gives the northern hemisphere more heat between January and July, but it hasn't been getting hotter between the Cambrian and now. Oh, yes, it has. Unless you think solar physicists and cosmologists have also joined the international Marxist conspiracy, the sun was around 6% weaker during the Cambrian, and it's been growing more powerful over time. A useful way of looking at this is to think of the Cambrian as Earth's winter, and today as its summer. When you take solar irradiance into account, Royer showed there's almost a perfect correlation between CO2 and global temperature. A paper published in 2010 called carbon dioxide the principal control knob of the Earth's temperature. Not understanding the implications of the sun's weakness leads Monckton into all sorts of other misconceptions.
750 million years ago, a mile of ice at the equator, ice planet all round, therefore, at the surface, 300,000 parts per million of CO2. Will you tell me how that much CO2 could have been in the atmosphere and yet allowed that amount of ice at the equator?
Well, I'm glad he's phrased this as a question, because it's a good question. It's a shame Monckton never tried to find the answer before hitting the stage and going to Congress with his own theories. If his debating opponent Tim Lambert will allow me, I'll be happy to answer it. The specific time Monckton's referring to is towards the end of what's colloquially known as Snowball Earth. The evidence of an Earth covered in ice is the discovery of glacial dropstones in rocks that were in the tropics over 700 million years ago. Given the weakness of the Sun at the time, an ice planet is no surprise. Since this is our geological winter, the Sun should have kept our planet permanently frozen, and the high albedo of ice would have kept it that way. The fact that it wasn't permanently frozen, a puzzle once called the faint sun paradox, is explained by the warming effect of greenhouse gases, primarily carbon dioxide. But if carbon dioxide levels fell, or some other event overcame this greenhouse effect, it wouldn't have taken much to tip the world into an ice age. The expanding ice reflected more of the already weak solar irradiation, a positive feedback, leading to more cooling, more ice and more reflection, until nearly the entire planet was covered with ice. Lambert explains quite rightly that the albedo of this ice planet would have been extremely high. Nearly all the solar radiation falling on it, which wasn't very much anyway because of the weaker sun, would have been reflected. There's no way the sun could have melted all this ice, and even Monckton wouldn't suggest such a thing. But something did, because within a few million years the ice had not only disappeared, the Earth had turned into a hothouse. Geologists say the explanation is very simple. The only part of the Earth not covered by ice were warm spots caused by volcanoes. They weren't enough to melt the area around them, let alone an entire planet made of ice, but they did release gases when they erupted, including carbon dioxide. Under normal conditions, this carbon dioxide would have reacted with rocks and rainwater to form carbonate minerals, which get washed out to sea. But in snowball Earth conditions, there's no rain, no chemical weathering, and no disposal of this carbon dioxide. It just kept building up in the atmosphere over millions of years to higher and higher concentrations, until eventually it reached a high enough concentration to overcome the weak sun and the high albedo of ice. So if you were to take a snapshot in time at the end of the last snowball, of course you'd find exceptionally high CO2 levels while glaciers were at the equator. But this is a dynamic process. It doesn't stand still like this. If we go back to the analogy of our winter cabin, let's say we've been away for months and it's covered in ice and frozen solid. The only way to unfreeze it is to put the heater on very high. When it's going full blast, take a picture. Does this tell you the heater obviously has no effect on the temperature of the cabin? I'm sure everyone knows the answer, but for the sake of those who don't, the answer is no. It means it takes a few hours or even days for the heater to do its work and melt all the ice. And if the heater keeps going, then you'll turn the cabin into a sauna. In exactly the same way, it took millions of years for the greenhouse warming from all that CO2 to completely melt the ice. Melting an ice planet takes a lot of heat, and physicists have calculated just how much was needed. It turns out that the level of CO2 in the atmosphere had to be 350 times what it is today. As the ice melted, open areas of ocean absorbed more heat from the sun, setting up positive feedback. So the melting accelerated. After the ice melted, the high levels of CO2 were still around, and the Earth's albedo was much lower, so temperatures kept rising. The Earth now swung the other way into a hothouse. So far from showing that carbon dioxide doesn't have any effect on temperatures, Snowball Earth shows the complete opposite. It confirms what other studies of the Earth's history have shown, that since output from the sun has been steadily rising, carbon dioxide is the key driver of long-term climate change on Earth. If something else unlocked a frozen Earth, and something else turned the Earth into a hothouse during that geological winter, Monckton doesn't explain what he thinks it was.
You're going to like this. I got this from Professor M.I. Bhatt of the Indian Geological Survey when I was asking him what was happening to the Himalayan glaciers. They're doing fine, by the way. He's got 200 years of records from the days of the Raj, when we first began monitoring these things, don't you know. And the glaciers are showing no particular change in 200 years. The only glacier that's declined a little is Gangotri, very famous glacier, because there's been local geological instability, nothing to do with global warming. All the others are doing fine.
We've heard a lot about Himalayan glaciers since the IPCC made that horrendous bungle predicting their disappearance by 2035. Lord Monckton says there's been no sign of change for 200 years, and none of the glaciers are even retreating, except one, and that's because of local geological instability. But once again, Monckton tells his audiences this without citing a source, except for someone called Professor Bhatt. So I wrote to Monckton to get his source. You quote M.I. Bhatt, but could you please cite the specific research paper where he published his study on this, if that is your source? If not, what was your source? I received this reply. Professor Bhatt is entirely clear as the man on the ground that there is no unusual pattern of glacial advance or recession in the Himalayas, and the locally produced literature tends to support this. Monckton attached a paper which didn't support his contention that Himalayan glaciers had been stable for 200 years. So I wrote back, I respect Professor Bhatt's opinion. The problem is I really need references to the published peer-reviewed research that it's based on. Has he or anyone written either a paper showing evidence that supports that opinion? When Monckton replied, he still gave no reference to a paper which substantiated his claim. But I did learn about the status of the mysterious Professor Bhatt. If you would like to learn more about Himalayan glaciers, talk to the guy who is responsible for monitoring them. And then he gave me the email address. It was becoming clear that Monckton had no research to back up his statement that the Himalayan glaciers had been stable for 200 years. Instead, he based all of his assertions on the word of Professor Bhatt, in the belief that he's the person responsible for monitoring Himalayan glaciers. So in order to verify his source, that needs to be substantiated. Back to Monckton again for an explanation. Isn't Professor Bhatt's research field tectonics, not glaciology? In what professional or official capacity is he the guy who is responsible for monitoring Himalayan glaciers? I got back a long discourse on the role of tectonics in glaciers and how the Himalayas are rising, another reference to the fact that the IPCC got it wrong, and puzzlement that I continued to demand references. Actually, I wasn't asking for references, I was asking Monckton to substantiate his claim that his source was the person responsible for monitoring Himalayan glaciers, and nowhere in his long email did he answer that question. But buried right at the bottom was the admission I'd been expecting. Yes, mountain glaciers in many regions, including the Himalayas, have been receding.
The glaciers are showing no particular change in 200 years.
Well, Mr. Monckton, now you know why I continue to ask, very politely by the way, for your sources. In the absence of any, you finally have to acknowledge the facts. When pressed for a source, you eventually say that they've been receding since the 1820s. Even this has no source, but I'm not going to chase up your sources every time you decide to change your mind about what you call the truth. But although I finally had Monckton's confession on the glaciers, I still didn't have an answer to my very simple question about his source. And when politicians evade questions, it means they're hiding something. By now I'd written to Dr. Bhatt and asked him this very question. Could I describe you as the person who is responsible for monitoring Himalayan glaciers? To which Bhatt had responded, the big and loud answer is no! So if Bhatt himself doesn't seem to think he was responsible for monitoring glaciers, I was curious as to what evidence Monckton had that he was. So I asked again. To recap, you said the source of your Himalayan glaciers claim is Dr. Bhatt, whom you describe as the guy who is responsible for monitoring them. Since this is your claim, I have to establish in what official or professional capacity Dr. Bhatt is the person responsible for monitoring Himalayan glaciers. This should be a fairly easy question to answer. Did I get an answer? No, of course not. But I did get the familiar Monckton climb down. No admission that what he said was wrong, just a quiet change of wording. Instead of being the guy responsible for monitoring Himalayan earthquakes, Professor Bhatt suddenly gets demoted to someone who merely seems to be knowledgeable. So with no admission that he got anything wrong, Monckton has now climbed all the way down from a speech where he told audiences that the Himalayas have shown no particular change in 200 years, based on the advice of the person responsible for monitoring them, to a claim that they've been retreating for nearly 200 years, based on the advice of someone who seems to be knowledgeable. And not a single peer-reviewed paper in sight.
Everything I say, I can and will, on request, verify, either in the data or with equations or in the peer-reviewed literature.